Combustion of fuel. Let's give a small introduction about this combustion. So combustion is just a chemical reaction where certain element like hydrogen, carbon reacts with oxygen to form heat energy. So as the heat energy is formed, the increase in temperature takes place inside the combustion chamber. Okay, so combustion is a chemical process or chemical reaction in which certain elements like hydrogen, carbon, etc. reacts with oxygen to produce the heat energy, and which will increase the inside temperature of the combustion chamber. So this is the definition of combustion. Next, what are the necessary conditions for this combustion? So, the necessary condition for this combustion are the presence of combustible mixture or the material. That means the mixture should have a good property which will helps in the combustion. Next, by means that initiating the process. It means the temperature, the pressure inside temperature condition of the cylinder, which will act as a factor to initiate the combustion process. Okay. So next is combustible mixture. So this combustible mixture, it may be homogeneous or heterogeneous. So in homogeneous mixture, the fuel and oxygen molecules will be uniformly distributed. Okay, this will uniformly distributed. In case of heterogeneous, the fuel and oxygen molecules will not uniformly distributed. So this combustion process will not be the same for the homogeneous and heterogeneous mixture. I want to give a basic concept of this combustion of fuel for this both heterogeneous and homogeneous mixture. So in case of SI engine, a nearly homogeneous air-fuel mixture is produced in carburetor outside the engine. Okay, but this combustion is initiated inside the cylinder at a particular instant at a certain velocity at the end of the compression stroke. Okay, so what I have said, that in SI engine you have to remember this, a homogeneous air fuel mixture is produced in the carburetor. Okay, so but in the outside of the engine, but the combustion initiated inside the engine, inside the cylinder at a particular instant at the end of the compression stroke. Next, what happens? Flame is produced. Okay, so flame is produced. Next, this flame has to be spread over the combustion mixture. So this flame has to be spread over the combustion mixture. So why? So simple reason is due to the heat transfer and you can say diffusion. So diffusion. Now what will be the direction of this flame propagation? So it is generally normal to the surface. Okay, so it is generally normal to the surface. Also it is known as normal speed of flame propagation. Right? Now, technically, in case of homogeneous mixture and heterogeneous mixture, the condition will be a bit different. So in case of homogeneous mixture, when phi means it is the ratio of actual air fuel ratio to the stoichiometric air fuel ratio. You may know about this stoichiometric air fuel ratio is that, so the amount of air to burn the fuel is enough, okay, but in actual air fuel ratio, the amount of air required to burn the fuel may be more than enough, more than the required value, or less than the required value, so which we known as rich mixture and lean mixture. So next, when we are talking about this phi, when this phi value is 1, the flame speed is approximately 40 centimeter per second in case of homogeneous mixture. So when phi is 1.1 to 1.2 and mixture is rich, okay, mixture is rich, then the flame speed will be maximum. So technically you have to remember this. Next, for heterogeneous mixture, you will have two situations. First is to initiate the combustion, next in the adjoining zone. So to initiate the combustion, the phi value should be 1.0 to 1.2 and rich mixture is required. Okay, but in adjoining zones, but we do not study about this in homogeneous mixture because we doesn't require this, because in homogeneous mixture all these fuel and oxygen molecules are uniformly distributed, so the same condition will be required for all over the combustion material or combustion mixture. But in case of heterogeneous mixture, the oxygen molecules and fuel will not be uniformly distributed. So in case of adjoining zone, so slightly lean mixture is required. And for the heterogeneous mixture, the rate of this combustion is determined by mutual diffusion of air and fuel mixture. Okay, so next we'll have this theoretical graph between the crack angle and the pressure. So it is a theoretical graph, so which describe the three stages that are compression, combustion and expansion. So from A to B, B to C and C to D. So it's a theoretical graph, but it doesn't happen in practical condition. What happens? Sir Ricardo, which is known as the father of the engine research, experiment about this combustion process and discuss three phase in his crack angle and pressure graph. So those are ignition lag stage, propagation of phase and after burning. Okay, so you can see this graph. So it has this mainly three stages. First, ignition lag stage, next flame propagation and next is after burning. So here point A at which this spark is given. Now it at about 20 degree BTDC. Okay, next at point B significant pressure rise takes place. You can see the significant pressure rise takes place. at B. Okay, it is about 8 degree BTDC. Now at point C, it is the maximum pressure, right? It is the maximum pressure. So stage AB is considered as first stage, stage BC is second stage, and stage CD is third stage. So let's discuss about it all three stages. So at the first stage, ignition lag stage is also known as preparation stage. So why? Because in this stage the growth and development of self-propagating nucleus of flames takes place. So it's just a chemical process which depends on this pressure, temperature, nature of the flame propagation of, and the exhaust propagation of exhaust residual gases. Okay, so our next stage is, our second stage is flame propagation. So it's just a physical process. So at point B, significant pressure rise takes place, and at C, the maximum pressure attained. So this is the peak pressure. So in this case, B to C, from B to C, the flame velocity is constant. So in this, the flame velocity is constant. Okay. Next, our third step after burning, that is CD. So from C to D, pressure decreases. So you can see in C, maximum pressure reach. From C, flame velocity decreases. Rate of the combustion become low. Okay. So in this stage, there you can see there is no pressure rise. Okay, in this stage there is no pressure rise takes place. So